Hello students. So we are doing straight lines. Okay. So next subtopic is the general form of a straight line. So how a straight line is written in terms of a variables. Okay. So we know the general form, that is ax plus by plus c equal to 0. Okay. Now we have to reduce this general form into the standard forms, that is slope intercept form or intercept form. Okay, so to reduce it to slope intercept form. So I'll write everything in terms of y, that is I'll write dy, ax I'll take that side and also c. Now dividing by b. Okay, so this is of the form y equal to mx plus c. Okay, so if you compare these two equations, you'll get m equal to minus a upon b and c is minus c upon b. So if you have the general form, okay, then a is the coefficient of x and b is the coefficient of y, right? What about c? C is the constant term, and b is the coefficient of y. Okay, so if you have the general form, you can directly write it in the slope intercept form. Okay. Next, we'll see to reduce it into intercept form. Okay. So it is of the form x upon a. We have to reduce it to this form, x upon a plus y upon b equal to 1. Okay. So I'll take this as a. I can write it as first. We'll write this as ax plus by equal to minus c. Okay. Now we have to make this side as 1. So divide by minus c, whole of the equation. Okay. So I can write this a upon minus c as x upon c upon a. Okay. Plus y upon minus c upon b equal to 1. So comparing this with the x by a and y by b, we get x intercept as minus c upon a and y intercept as minus c upon b. Okay, so you can directly take these values from the general form and write your intercept form. Okay. Next, we'll reduce it to normal form. Okay, that is our perpendicular or normal form. So ax plus by plus c equal to 0. This we have to write as x upon cos alpha plus y sin alpha. This is our normal form equation equal to 0. So if you divide uh, these two equations, that is a upon cos alpha, b upon sin alpha and c upon minus b. Okay, so our cos alpha will take a upon cos alpha equal to c upon minus b, and b upon sine alpha equal to c upon minus. Okay, so multiplying we will get cos alpha as minus ap upon c and sine alpha as minus bp upon c. Okay, so if you square this, what you will get? Squaring and adding you will get 1, right? So sine square alpha plus cos square alpha is equal to minus ap whole square. So minus gets cancelled. So ap square, that is a square p square upon c square, plus b square p square upon c square. Okay, that is equal to 1. So p square upon c square, you can take common. So a square plus b square equal to 1. Okay. So from this we can write p square, value of p square is c square upon a square plus b square. Okay, so p is nothing but plus or minus c upon root of a square plus b square. Okay, so this is the value of p. So now we have to write cos alpha and sin alpha in terms of a and b. Okay, so here we can substitute value of p, that is in terms of ABC. Okay, this we are doing because we want everything in terms of A, B and C, because our general form is given and we have to write that perpendicular form using general form, values of general form. Okay, so cos alpha, you can substitute P here. So cos alpha is minus a upon c into c upon root of a square plus b square. Okay, and this is for a there are two values of p, right? So for a positive value this comes, for a negative value this becomes positive. CC gets cancelled, so we'll get a upon root of a square plus b square. Okay, what about sine alpha? Same way, so b upon will get. For a positive value of p, we will get minus b upon root of a square plus b square. And for this it is b upon root of a square plus b square. Okay. So finally, when you write the equation in the normal form, it is x cos alpha. So x cos alpha is, I'll write two values will be there. So I'll write for negative value. Okay. A upon root of a square plus b square plus y sin alpha minus or equal to p it is. So p value you have to write c upon root of a square plus b square. Okay. Let's solve some examples. So the question is you have to reduce the following equation into slope intercept form. Okay. So first question is given root 3x plus y plus 1 equal to 0. Now this is your ax general form plus by plus c equal to 0. Okay. What is a? Root 3. B is 1. C is 1. Okay. Either you can use those formulas, okay, or you can directly write this in the form y equal to mx plus c. Okay, that is this equation you take, y you keep here only, root 3x, and that 1 goes that side. So this you have to compare with y equal to mx plus c. So what is the value of m? M is minus root 3, and what is the value of c? Minus 1. Okay, so this is your slope and this is your intercept. Okay, so this is pretty easy. Second equation, you reduce the following equation into intercept form and find the intercepts on x-axis. So you have to reduce it to intercept form. Equation is given 7y plus 3 equal to 0. So this form you have to reduce. Same way you can reduce. That is, you have to first take this 3 that side, then divide the whole equation by minus 3. Okay, so here it will be 1. This you can write it as minus 3 by 2. This has to be plus. So it gets cancelled, right? On 3 by 7, you have to make it plus, okay? This negative sign you can take for the denominator if it doesn't cancel. Okay. So the value of A is minus 3 by 2 x-intercept, and value of B y-intercept is 3 by 7. Okay. Let's do one question for the normal form. Okay. So you have to write the length of the perpendicular from the origin to line. Okay, that is P value you have to write. And secondly, angle between the normal and the positive x-axis. Okay. So the question is given with 3x plus y minus 8 equal to 0. Okay. Write ABC. B is 1, C is minus 8. Okay. So what is the value of P? P is plus or minus C upon root of A square plus B square. Okay, so this is P. Then we have to write cos alpha. Cos alpha is A upon, that is plus or minus 1. A upon root of A square plus B square. Sin alpha, same way, plus or minus root of 1, not root, just B plus 1. So this root is root 3 and square, so 3 you will get. 3 plus 1, 4, so root of 4 is 2. Okay, 2. Okay, so they have asked length of the perpendicular and angle between normal and the positive x-axis. Now positive x-axis means all the values will be positive. Okay, so you have to take positive values. So this P will be 4. This is root 3 by 2. And this is half. Okay, so we have to write P is the perpendicular distance. Then we have to write the angle. So cos alpha is this. and cos sin alpha is this. So looking at the alpha and the values, we'll get that alpha is 30 degree. Okay, so the final equation, that is normal form, is x cos 30 degree plus y sin 30 degree equal to 4. Okay, so this is the normal form of the equation. Next subtopic is distance of a point from a line. Distance of a point from a line. Actually, it is a perpendicular distance. Okay, so if you have a line, say, and this is perpendicular, and this is that point. Okay. So equation of the line is ax plus by plus c equal to 0. Okay. This point is x1, y1. Okay. So the perpendicular distance is given by, and write here perpendicular, d equal to mod of ax1 plus by1 plus c upon root of a square plus b square. Okay, this is for the perpendicular distance. Now there is one more formula, that is distance between the two parallel lines. So if you have two parallel lines, say, the distance will be perpendicular, right? Distance between two parallel lines. So the lines are like this. Okay. Distance is here perpendicular. So the distance is given by two parallel lines. So the equation of the lines, you can write y is equal to mx plus c1. Since both the lines are parallel, the slopes are equal. Okay. The intercepts are different. Y-intercepts. Okay. So we have the distance as d equal to mod of c1 minus c2 upon root of 1 plus m square. If the equations are given in this form, that is slope-intercept form. If the equations are given in the your general form, that is ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0, then the equation is d equal to c1 minus c2 upon root of a square plus b square. Okay, so these are the two formulas for the distance between the two parallel lines. Let's do one example. So example which is given in the textbook, find the distance of the point 3, minus 5 from the line. So line equation is given 3x minus 4y minus 26 equal to 0. First you write the general form. Okay. The point is 3, minus 5. Okay. So you have to find the distance. Distance is given by ax1 plus by1 plus c upon root of a square plus b square. So this is your x1, y1. A is 3, 3 into 3. B is minus 4 and this is also minus, plus c minus 26. Root of a square 9, b square 16. Okay. So this is 9 plus 20 minus 26 root of 25. So this is minus 6. Minus 6 plus 9 is 3. So 3 upon 5 units. Okay, this is the distance. Next question is you have to find the distance between the parallel lines. So lines are given in the general form. 3x minus 4y plus 7 equal to 0. So this is your ax plus by plus c1 equal to 0. Second it is 3x minus 4y plus 5 equal to 0. So if you have say the equations are given and only C1 and C2 are different, okay, A and B are same, then you can say that the lines are parallel, right? Because slope comes equal, right? So distance is C1 minus C2 upon root of A square plus B square. So C1 minus C2 upon root of A square is 3 square 4 square 2 9 plus 16. So again 2 upon 5 is the answer.